Class, we're now going to use what we've learned about spectrophotometry to answer a question we need answered. We have a sample of a compound in stock called copper 2-chloride dihydrate. It's this nice kind of bluish pinkish compound. And what we need to do is we need to figure out whether any waters of hydration have been lost. So we know that if you heat up a hydrated compound, you can drive off the waters of hydration. And what we need to know about this sample is whether or not that has happened inadvertently and that the compound has lost some of those waters of hydration. So what we've done is we've made up a series of standard solutions of copper, for which we will measure the absorbance, and we've made up a solution that contains a known mass of our copper 2-chloride sample. And what we'll be able to do is be able to make a working curve from the known solutions and then figure out the moles of copper in here, and from that be able to figure out the molar mass of our copper 2-chloride sample that we have, and from that be able to determine whether or not any waters have been lost or not. So let's go over the method of our analysis. The idea is that hydrated compounds have waters of hydration that can be lost. And so if this compound loses its waters of hydration, you'll be changing from copper 2-chloride dihydrate to anhydrous copper 2-chloride, and the waters are lost to the gas phase. And so if that happens, the mass of the sample will decrease because you'll be losing the waters to the gas phase. And if you measure the molar mass of the sample that you have, the number of moles of copper will have stayed the same, but the mass will decrease. So the apparent molar mass will decrease. And it'll start out, if all the waters of hydration are still present, the molar mass will be 170 grams per mole. If all of the waters of hydration are lost, then it'll drop all the way down to 134. So it should be easy to see if it's happened significantly. So the question to be answered is, has this happened? Has our sample lost those waters of hydration? And the way we'll answer it is we're going to answer it by measuring the apparent molar mass of the sample, and from that we'll compare it to the known molar masses of the hydrate and the anhydrous and see if it's changed much. The pathway to get there is this. The experimental pathway to get there is we'll make known solutions that contain copper 2 ions of known concentration. Those will be our standard solutions. We'll determine the lambda max of the UV visible spectrum for that, and then measure the absorbance at that maximum for the standard solutions. We'll create a standard curve of absorbance versus copper 2 plus. We'll find the equation for the straight line that goes through that. Then we'll make a solution containing a known mass of the sample that is ostensibly the copper 2-chloride dihydrate, but may have lost the hydrates. We'll measure its absorbance, and from that we'll determine the molar mass of the hydrated sample. And again, if the molar mass is significantly less than that of the dihydrate, then we know that waters have been lost. We'll do the experiment first, and then after that we'll explain how to do the calculations.